Leetcode 23, merge k sorted lists. It's classified as hard, but don't get scared. Previously we solved merge two sorted lists, and if you haven't solved this one, then please at least solve it on your own, since the core of the solution is exactly the same between those two. Yeah, so of course it's a bit harder to generalize to k sorted lists, but more or less like the heart or the core of the solution stays exactly the same. Yeah, so if you know how to solve it for two, you should be able to make this step and solve for k as well. And that's why I think that is not really the hardest of hard. Yeah, so it's classified as hard, but you shouldn't get scared. If you know how to solve this previous problem, this one shouldn't be much harder. Yeah, so maybe it's maybe medium would be more appropriate in this particular case. But they classified it as hard. So here is the description. You are given an array of k linked lists called lists. Each linked list is sorted in an in ascending order. So a lot to unpack. There is like lists here, linked lists, array lists, and so on. So first of all, there are inside the code on the right side, we will only be operating on objects of this class, list node. Yeah? And if you take a look, it stores exactly two things. Value, which is the data or the label for each element or each node, as they called here, of the list, and connection to the next element, which can be either the next element, so the next object of that class, or none in case when we reach the end. Yeah, so the last element of the list will store none here for the next connection. Yeah. So that's the most important thing, and there won't be any like data structure or some kind of object called list. We only operate on those individual nodes, and because they have those connections, that's why together they form a list. Yeah, but this list, like this group, only exists, or like we only think of them as group. Yeah, inside the code there is no structure or class or object that is called list itself. Yeah, so that's the first important point. And the second is that these lists, that input that they are here describing as an array, and here is a here they are using a list from Python, this type. This is like a different list. So that's why I'm telling you that it's confusing, since this list node is something else as this list. This is just a Python list container where we store objects, any number or k, exactly k objects of this class. And each of those objects points to, or is the first element or the head of its own list. Yeah, but for each of them, there won't be any list. There will be just many objects that will be connected through this next. And I think that as we go with examples, it should be a little bit clearer for you. At least I hope so. But just trying to highlight and emphasize at the very beginning that it might be confusing, since they are using the same name for different things. And just the last thing here to note is that this elements of the list, of the Python list, are optional. Yeah, so there could be none or could be empty inside. And yeah, so that's the first part. We will have k objects of this list node inside this input list, which is called lists. And for them, they will be always connected in such a way that those values that they store, that the first one will have the smallest value, and each one will have the same value. Each next will have either the same or greater. Yeah, so they will be sorted in ascending order. So that's guaranteed from here. So at least we have this constraint, and we can be sure that it will be like this. And the task is to merge all the linked lists into one sorted linked list and return it. Yeah, and here is next confusing thing. As you can see here, they are using as input Python lists, but that is not what is going on here. That's not the same thing. So it's confusing. It happens a lot in Leetcode, but you have to always consider or use what is written on the right side. Yeah, here is just an example, which is for you maybe to start imagining how can you think about this problem, but the real stuff is happening on the right side. So here, let's maybe copy that since there's a lot going on, and try to convert it from Python lists to more linked list approach. So we will have 3 lists, or we are given 3 lists. And let's draw them like this: 4 and 5. Just copy from here. Like this: 1, 3, 4, and 2 and 6. And so that's our input. And what is exactly our input? That's the most important. Yeah. So here they claim that this is the input, but it's not the case. Inside our lists here, we will be given only first instance, the head from each list, not the whole list. But because each one stores a connection, we can recreate the list by going through this next property. And let's maybe change the background, maybe to green. Yeah. So those first objects there will be sitting inside this input. Yeah. And how do we get the next element? By accessing .next. So that's the first thing. And then there is some explanation. And the output should be like this. Write it down here: input and output. And how can we arrive at this output? Yeah. We need to find the smallest element between all the lists that we haven't used so far. That's it. Yeah, that's the task. Let's mark it like this. We can even push it to the bottom and change the background like that. Yeah, so that is highlighted in that manner. And how can we do this? We can either each time loop through each list or through each head of each list, and we will be moving head. We can even write it down here. So there will be like head 1, head 2, and head 3. Yeah, and those will be progressing as we will be using elements. So either we can every time just loop through each head, or we can use some additional data structure that will keep an order, since we always want to find the smallest. So how can we find the smallest? One option is use a loop, and each time compare all the heads. And that is like the most either naive approach or like the simplest approach that you can think of, and this will work, of course. But there's another one. You can use some special data structure that will impose order on its own. and might be faster. So we will use the second approach, but just for the sake of clarity, for sure everyone first will think about looping. Yeah, but there is another thing that you might use here, which is special data structure. And there are a couple data structure that you can use, but I will choose heap, for example, heap. Yeah. And if you use this data structure, you may get you may be a little bit faster, and you may get better time complexity. We will talk about it in a second, but just right now, whatever option we will use, we either way in each case we will always choose the smallest thing. And right now we haven't used anything, so if we were to construct an output using an algorithm, we would still get 1 as our head, and then we have an option to either take it from here or from here, but usually we would just take the order in which they come. So we can progress this head here, and this thing, this element has been already used. We have to mark it in some way, and usually we just mark it in lists by progressing, by overwriting and using this next property. And that's how it's done, so that we know that we have already used it and we move to the next one. Yeah, and so on and so forth. Then we can use this. And then we will use, of course, this. Sorry, will not cut, but just copy and paste. And then from here, we can now change the background. So here, those were the initial heads, and now we have progressed. So we can update using advanced animation techniques. And the next smallest element is 3. And of course, the arrow goes on this side. As we use this, we progress the head here, we update, and so on and so forth. Yeah. Then we take 4. And then this 4, and the head goes outside. And we know that terminated, since there is nothing else. Yeah, so in the code we'll have to check if not none or something like this, because once we reach the end, the head will be pointing to none. Yeah, or will be none, simply. We will just overwrite it with none, and we have another 4, and then we can start new line with 5 and 6. And that's it. And that's how it will go. Yeah, but here I was just choosing the smallest object with my hand, but inside the code we can use heap, which will impose the order on its own, and we can just use pop operation. We can even write it down that it has pop and push, pop. Yeah, and once you do push, it will place it in such a way that it will know later where is the smallest, and once you use pop, it will just return the smallest that is currently there. And this will the pop will work, or both push and pop will work in log k with all log k time complexity. Yeah, so because we will have k lists, let's make it thinner. Yeah, and at most n elements. That means that the whole operation through heap will be n times log k, but if you are using loop, the cost of this operation would be k times n. Yeah, so let's write it down. And this one. And log k, like this. Okay, so this is one approach in which you can solve this problem. Now let's go and try to implement it. Have to import heap queue. And now let me think. First, we'll construct a queue or construct a heap. Iterate through or pop from the heap until empty and return the result. And what is the result, by the way? That's important thing. So here they are expecting optional list node. Yeah, so either none or object of list node. But which object? Yeah, the one that is pointing to the head of the newly constructed list. So in order to do this, we have to somehow keep track of it. And one way is to use so-called dummy list node, which will be an additional list node, which we create outside of all of them, since we don't know which head initially will be used as the first head. Yeah, and we will simply point once we select it, we will point use this dummy list node to point to the first head, and we'll leave it like this. Yeah, it will just we'll use it once for that, and leave it like this, and by the end we will return to which this dummy list node object is pointing. Yeah. And in that way we can keep track of the new head. Yes, we don't know initially which one will be the best. We can, of course, use some other way. There are multiple ways in which you can do it, but this is, I think, one of the cleanest. Yes. So, by the way, we can already construct it. Since we were talking about it. And for the iteration and for constructing of this new list, we will use tail, which initially will be dummy. Yeah, but then we will progress the tail and dummy will stay the way it is. And at the end, we can return dummy next. So now, how to construct the heap? So for sure, we have to get each element of the initial list. And just to remind you, each element of the initial list are those first heads. Yeah, so first heads, just heads of each of the list that we will be using. And for that, we can do it in this manner for head in lists. But there will be one problem. I will mention it in a second, but let's just get to it. And we have to also take into consideration that it's optional, so it could be none. So if head, so if it's not none, we can check like this. We can leave it like this. I think that's more Pythonic. And what do we want to do here? We want to use heap queue, heap push. And heap push needs a collection in which it will insert the new element. So we will create our heap like this. Yeah. So the heap queue itself will implement or already implements all the heap operations, both push and pop, but the underlying container in which data will be stored can still be a list. And here we just push our container, push or use as a first parameter. And now here is the thing. We want to sort by value. Yeah, so that will be the first element inside the tuple. And of course, besides the value, we need the node object itself. But the thing is, as we had here, that two different values, like two elements from various lists or even in the same list can be repeated. Yeah, so it's not necessarily the case, or for sure it's not the case, that values are unique. And in this case, we need to also use index to make them unique, and so to not lose any nodes. And enumerate. If we use enumerate, then we are getting both index and the value. And here, like that. I think that's it. And now, while there are still things in the heap, we will be popping, and the next value slash index slash node is equal to heap queue heap pop from the heap. And now, what are we supposed to do with this? Yeah. Index is only used for the heap itself internally. Value, we use it for sorting. We don't need it anymore. We need the nodes. And where are we creating our output list? Inside the tail, as we said here. Yeah, we'll be just adding to the tail and progressing it as we go. And tail equals to the node, and tail equals tail. Next. Yeah, like this. And then we have to check if the node itself has anything after it, or is it the last element. If it's last element, then this if will be false. But if not, we need to add again. And this time we are not adding the head, but node next. And that's it. So let's see. Everything works fine for the first three cases, and now on all the cases we beat 92% of the people when it comes to runtime.